Hello guys, Smart Poly here, and welcome to how to make a first-person shooter game inside of Unreal Engine 5.4. In this beginner tutorial, I will show you how to create this simple first-person shooter game that you see here from complete scratch. No matter if you are a complete beginner, this tutorial will show you step-by-step how to create this first-person shooter game. We will start by importing a custom character mesh from the Unreal Engine Marketplace. We will add some custom animations and set up the character blueprint. We will give our character a simple rifle weapon, which we will add some aim logic to aim down sights, and we will add things like sprinting and sprint animations. Then next up, we will add our basic weapon fire logic so that we will fire a simple line trace, and we will add things like bullet hole decals when we shoot the wall, and also things like procedural recoil for our rifle weapon. Next, we will learn how to create user interface by creating a dynamic crosshair that will spread out if our character strafes left or right. Then we will add this simple target blueprint that the player can shoot to practice their aim. We will also add things like reload logic so that the player can see how much ammo they have on their screen and they'll be able to reload their weapon. And after that, I will show you how to create a custom aim range map. You'll create this simple map from complete scratch using free assets from the Unreal Engine Marketplace and Quixel Bridge. We will completely decorate this level using different props. I will show you how to modify things like the material colors, add in graffiti decals from Quixel Bridge, how to fix things like the mesh collisions, and much more. And we will add this moving aim range part of the map that will feature moving targets that the player can practice their aim on. And once we finish completing the map, we will add things like controller input support so we can play our game using any type of controller. Then finally, at the very end of this video, I will wrap up this tutorial by showing you how to package the game for a Windows PC so that you can send this game to your friends or play it on another computer or device. And if you guys end up enjoying this video, make sure you hit the like button and consider subscribing, as I'm going to be making more future courses and tutorials like this on my YouTube channel, and you guys do not want to miss out on any future uploads. Also, don't forget to leave a comment down below. It helps push this video to the YouTube algorithm. And just let me know in the comments what type of game you want me to make a tutorial on next. Should I make a RPG game, a GTA 5 style game, a battle royale game? Let me know down in the comments down below. Also, before we get into the video, if you guys genuinely want to know what it takes to create a open world game inside of Unreal Engine 5, I have a complete multiplayer survival game course. This course has over 70 hours of course content, and it teaches you skills and things that you cannot fit into a simple YouTube video. There is no other course like this on the internet that will show you from scratch, step by step, how to create a multiplayer Steam survival game inside of Unreal Engine 5. You will learn how to create a drag and drop inventory system, a crafting system where you can craft all sorts of different items, a harvesting system where you can chop down trees, you can mine rocks and pick bushes. We create an open world map that features a swimmable ocean, lakes, rivers, mountains, and much more. We create a procedural spawning AI system, a base building system and rating system, and we add Steam voice chat, player tribes, and so much more. This course has over 250 lectures, which spans over 20 chapters and over 70 plus hours of course content. So check out the multiplayer survival game course bundle on my website, smartpoly.teachable.com, and make sure you pick up the course before I raise the price of the bundle later on. I also have another course you guys can check out. It shows you how to make a cross-platform mobile game inside of Unreal Engine 5. It features a simple prop hunt game that is multiplayer. You guys can check it out on my website, and if you purchase my survival game course, you can actually get it bundled with the purchase when you add it to your cart and check out. So check out my course on my website, smartpoly.teachable.com. I'll leave a link to it in the description below. And without further ado, let's get right into the video. Hello and welcome to the Unreal Engine 5 first-person shooter game beginner tutorial. I want to set some expectations for this course. First and foremost, this is a beginner's course. However, I will not be showing how to download and install Unreal Engine 5 in this particular video, nor will I be showing or explaining the basic controls or user interface of the engine. I expect you, at the very least, to have Unreal Engine 5 downloaded and installed, and at least know some very basic knowledge of the controls and user interface. Now, if you do not have Unreal Engine 5 downloaded, or if you're not familiar with the user interface, I recommend that you pause this video right now and go watch my Unreal Engine 5 complete beginner tutorial, as this shows you how to download and install Unreal Engine 5, and it explains in great depth the user interface for a complete beginner. The second thing is I will be showing how to create everything in Blueprint, which is Unreal Engine Visual's scripting system. It allows anyone to make games inside of Unreal Engine without having to type a single line of code or without having to know how to write code. I will not be explaining the basics of Blueprint, but I will show you step by step everything that you need to know and everything that you need to do, as well as explain the logic behind the blueprint that we create. Now, if you are a complete beginner to blueprints, and if you have no idea what are blueprints, I suggest that you pause this video and go watch my blueprint for beginners tutorial, as this will explain what are blueprints and everything that you need to know as a complete beginner. Now, with all of that out of the way, I can safely assume that you have at least Unreal Engine 5 installed, and you have some basic knowledge of the user interface and controls. You also have some basic knowledge of blueprint, so we can go ahead and begin with this course. Alright, so the first thing that we're going to go ahead and do is launch Unreal Engine. So you want to open up the Epic Game Launcher and go ahead and click. Alright, so the first thing that we're going to go ahead and do is launch Unreal Engine. So you want to open up the Epic Game Launcher and go ahead and click the launch for Unreal Engine 5.4.4. And once you've launched the engine, you want to go ahead and select the game's template over here. And on the game's template, we'll choose the first person template since it has a simple first person character set up. And for the project name, we can go ahead and rename this to our FPS game tutorial and then just click create. So once you go ahead and click create on your project, this is what it will look like when you open it up. And I'll show you guys what it looks like when you play the template. So when you hit the play button, if I close my content browser, you can see we have the simple first-person character controller. There's actually this gun weapon that you can run up and pick up. And if you left-click on this weapon, you can see that it fires this yellow ball. So it's just a very simple first-person shooter game template. And we're going to modify this template and import our own custom character, add our own custom weapon, and completely modify it. So the way that we'll do that is first let's dock our content drawer. So open up your content drawer and dock it in the layout. That way we can see all of our content. And in our content folder, we're going to right click and create a new folder and name this to _main, just so we can organize all of our assets. The underscore, we'll just keep it at the very front of our project files right here. So double click and open that up, and we'll need to go ahead and import our own custom character. So we'll actually get that from the Unreal Engine Marketplace. So you want to go ahead and open up the Epic Games Launcher. And once you've opened up the Epic Games Launcher, you want to head over to the Marketplace tab. This is where we'll go ahead and download any sort of free assets that we'll be using for our FPS game. So under the products, you want to search for military, and then you want to filter and click on the free under the max price. So this will show us all the things related to military that are free. And in our case, we want this military character silver. So if you click on it, we have the simple military character, and this will be the character that we'll be using for our player character. So you want to click on add a project, and you're not going to see your project, so you want to click on show all projects, and then you want to search for our FPS game tutorial and select the project, and you're going to see asset is not compatible with version 5.4. Please select closest alternative version. Basically, this means that this military character hasn't been updated to this version of the engine, which is Unreal Engine 5.4. So we have to select the closest alternative version. So all you have to do is hit this drop down right here and select the closest version, which is 4.27. And as you can see, that error message goes away, and now we can actually click the add to project. So that will go ahead and download it and add it to our project. And once that's done, we should have a folder for military character silver over here. So you can see we have this character. So let's actually go back to our content folder, and it looks like it deleted our _main. So let's just right click and create a new folder, name that to _main. For whatever reason, it deleted the folder, but that's okay. Just go ahead and double click, open that up. And in here, we're going to create a new folder for our animations. So right click, create a new folder, and name this to animations. And double click, open that up. And we're going to import some custom animations as well as our custom character mesh into this project. We already have this military character over here, but it's the full body, and we only need the arms, since we're only going to be seeing the arms in first person. So you want to go back to your animations folder, and then you want to take your project and minimize it like this, so it's in windowed mode. And then you want to head over to the description of this video, and there will be a link to my Patreon where you can download the project files for this course. So once you've downloaded the project files from my Patreon, you can double click and open them up. And in there will be a folder for animations. And you want to take your project side by side. Go to your main animations folder, and first we're going to take this skcharacter.fpx and drag and drop it into our folder. And we're going to get this pop up for FBX import options. You want to leave it as the defaults. The skeletal mesh is checked to true, import mesh is true. There's nothing in the skeleton, and everything is as the defaults. I'm just going to click import all, and you can see that we have this No smoothing group information was found. We can just ignore that, close that X. But what you should see is we have all 4 of these files. So let's do a file, save all. We have this material, which we'll actually delete. You can delete this material. Click force delete. But we have our character mesh, our physics asset, and our skeleton. Now what we want to do is we want to import the animations. So let's select all of these following files up here. These are all the animations. Now let's drag and drop it into our folder. Then it's going to ask us which skeleton to import this on. In our case, we have the SK character skeleton, the one that we just imported, which is the skeleton that we want to import this onto. So once we have that done, we can just click import all, and now we'll go ahead and import all the animations. So now let's do a file, save all, and now we've successfully imported all of our animations into our project. And so now let's go ahead and open up our SK character. So if we open up this SK character, and let's take this window and dock it up here at the top. Now whenever you open up a window, we can actually go to our editor preferences, and whenever you open up a new window under this asset editor open location, you can make it open up on the main window. That way, whenever you double click and open up a file, it will automatically dock it here at the top. Anyways, in our SK character, this is basically the military character that we downloaded from the marketplace, but it's just the arms. So under the material slots, you can hit the drop down and search for military. And we should have this military M male instance. So if you select that, you can see that it'll apply the texture, the military character texture or material to the arms. And then we can just save that. Now we have our animations here. We have things like our rifle idle animation, things like our rifle run and fire, aim. So we have all of our animations. Now we want to set it up for our character. That way we can see our animations and also see our custom character mesh. So the way that we'll set up our animations is first through a animation blend space. So we want to create a animation blend space, and simply what the blend space is it's a asset that will allow us to blend between one or more animations. So in our case, we want to blend between an idle animation where our character is holding the gun, and then a walk animation where the character is maybe walking forward, and then a sprinting animation where the character is sprinting with the rifle. So we're going to blend between these animations, and to do that we'll need a blend space. So right click and create a new animation blend space, and we'll need to select a skeleton to add this blend space under. So in our case we want to select the skeleton that we imported, which was our SK character skeleton. So make sure that this is the SK character skeleton. And then we'll add that file, and we'll just rename this to blend space underscore idle walk run. And then just double click and open that blend space up. So in here, this is the blend space. Basically, you have a viewports, which will preview the animation. Then down here, you have the graph, which will allow us to drag in various different animations on the graph and blend between those animations. On the bottom right, you have the asset browser, which will show you all the animations you have to work with. And then on the left here, you have the asset details, which will allow you to control things like the axis settings or the settings for this graph. So we actually want to modify the settings for this graph. So in the axis settings, we're going to expand this horizontal axis. So the horizontal axis is this axis down here. And so for the name, we can rename this to speed. And as you can see, when we update that name, it will update the name down here. And so we can update things like the minimum and maximum value on this axis. So in our case, the minimum value will be 0. And then the maximum value, we can change this to 800. And then we can save that. And now that we set that value, you can see that we have a value of 0 to 800 for our speed. So basically, this is our character speed. So 0 will be idle and 800 will be sprinting. And then somewhere in between will be where the character is walking. So now we can drag in animations into our blend space. So to do that, you just want to select our rifle idle or idle animation and drag and drop it onto the graph. So when you drag and drop it on the graph, you can see that it adds this little dot. And so if you hover over it, it's the rifle idle animation. And you can see it's playing our rifle idle animation. So you want to take this dot and position it down here at the very bottom. And if you actually hold down Shift, it will allow you to snap this animation to the grid. So we want to snap it down here at 0, 0. So you can see it's playing our rifle idle animation. Now we want to get our rifle run. So we have this rifle run animation. We want to drag that on the graph and also press shift. And as you can see, it'll allow us to snap it. And we want to snap it down here in the middle. And if you actually click on this button over here, show sample names, it will show us the names of our animations. Now this animation in particular, we actually want to move this to the value of 500. So if you select this animation, we can change the value. So we can change the speed value to 500. And it will place it at speed value 500. So basically, if you hold down Control, that will allow you to move this green cursor. And that will allow us to preview the blending between these two animations. So we have our rifle idle, which is just idle. But if we move our green cursor by hitting Control, or holding down Control, you can see that we can blend between our rifle run and our rifle idle. So based on the character's speed, that will allow us to blend between these two animations. Lastly, we want to take our rifle roadie run. This is basically like our sprint, and just shift and drag it on the graph to the very end at the value of 800. So now if you hold down Control and preview what it will look like, we have our sprint, we have our walk, and we have our idle. Now we actually want to adjust this roadie run over here, this last one. So down here, in the asset details under the samples, we can expand this rifle roadie run, and we can actually adjust things like the rate scale, and that will adjust how intense the animation is. So if I preview it, you can see that it's pretty intense. So I can change the rate scale down to 0.8, and it won't be as intense of the animation. You can see it's playing at a lower or slower scale. And I've just played around with these values. That's why I got that value there. But that is all that we need to do. We have our simple blend space, which allows us to blend between one or more animations. In our case, we're blending between our rifle idle, our rifle run, and our rifle roadie run. So save that and we can close out of there. And now what we'll need is we'll need to create an animation blueprint, which will basically tie together our animation blend space with our character blueprint. So the reason why we'll need to create that is because we need to tell the blend space what our character's movement speed is in order for it to know what animation to play or blend through. And we'll do that through the animation blueprint. So right click and create a new animation asset. And we want to select this animation blueprint. Then it's going to ask us to pick a skeleton. So again, you want to search for your sk_character skeleton, the one that we're using, and click create. And we'll rename this to animation blueprint, or ABP for short, _player character. And then let's go ahead and double click and open up this animation blueprint up. The very first time that you open up an animation blueprint, if you're not familiar with the animation blueprint, basically you have your viewport over here where you can preview your animation. Over here on the middle section, we have a graph, two graphs. We have the event graph, which will allow you to add things like blueprint nodes and retrieve information from your character. Then you have the anim graph, which will allow you to plug in animations to determine which animation should be playing on your character. So for us, we're going to start here on the anim graph. So off of this output pose, off of the result, we can drag off of here and add a state machine. So we want to add this animation state machine. And that will add this new state machine. Then in here, we can actually double click on this and that will open up that state machine. So as you can see, we're now in that new state machine. And if you want to go back, you can click back to the anim graph. So just note that you can go back or back into it by just navigating through these little tabs. But inside here, we have this entry or this little arrow that you can actually drag off and it creates an arrow. So in our case, we need to create a new state inside of our state machine. So just drag and drop this arrow on the graph and add a new state. So click on the add state. And we're going to rename this state to our idle walk run state. This will just be our simple idle walk run state. And now if we actually double click on this, will allow us to open up that state. And in here, you're going to see that we have this animation output pose and we have another result pin that we can plug into. So if we plug in an animation, that will output the animation for the result, and we should be able to preview it on our character. So what we want to do in here is we actually want to input our idle walk run blend space. So what you should notice down here in the bottom right is we have the asset browser. That will allow us to drag in any animation asset into our graph and output that as our animation result. So we want to take our idle walk run blend space right over here, drag it on the graph, and that will add this blend space node. And as you can see, we have these two pins, these two human icon pins, and we can just plug in that for the result. And now to see this in action, we just want to hit the compile and save. And now you can see that it's playing our blend space You can see that we have this execution flow. It's showing us that it's playing our idle walk run blend space. And you can see that we're previewing our animation, which is just a simple idle animation. So now all we have to do is bind this speed to our character's movement speed from our character blueprint. So the way that we'll control that value is by promoting this speed to a variable that we will set in our event graph. So take the speed and drag it and drop it on the graph, and you want to click on this promote to variable. And that will add a new variable down in the variables tab called speed. So just click anywhere else on the graph and that will add it, and just hit compile and save. And now we have this green variable, which is a float, bound to our speed for our blend space. So now all we have to do is set the speed variable in our event graph. So let's head over to our event graph. And in here we have an event update animation. So the way that this works is we have a reference to our character off of this try get pawn owner. So this will get the owner of this animation blueprint, which is our character. So off of this return value, we want to do a is valid check. We have this question mark. So select that node and hook up the execution. We have this execution node. We'll plug it in like so. Hit the compile and save. And now what we're doing is every time we're updating this animation, we're getting our owner of this character blueprint, which should be our character, checking to see if it's valid. And if so, we can then set our speed variable based on our character's movement speed. So to get our character's movement speed, we have a reference to our character. So just drag off of here and we can get things like our velocity. So we want to get the character's velocity. So get velocity of our character, and then we want to take this velocity value, which is this vector, this yellow vector, and convert that to a float. So we want to get the vector length. So vector length, and that will change that vector into a float, which we can then use to set our speed. So take our speed variable and set it on the graph, hook this up for our is valid, so only if our character reference is valid. We want to set our speed to our velocity or the vector length of our velocity. So then hit the compile and save. And now what we're doing is we're getting our character's movement speed and we're setting it to this variable, which we're then using inside of our state machine in our idle walk run state for our blend space to determine what animation should we be playing in the blend space based on our character's movement speed. So now we should be able to actually add this animation blueprint to our character blueprint by just opening up our character blueprint and assigning it. So let's go ahead and do that. So let's go to our blueprints. So go to your content folder, and we should have a folder for first person. So double click, open that up. And in there we have a folder for blueprints. And what you should notice is we have this BP first person character. So if we actually double click and open up this BP first person character, this is the blueprint character that we played as when we hit the green play button. Over here, we have 3 different tabs. We want to head over to the viewport tab. In the viewport, you can see what components make up this first person character. In our case, we have a simple camera component. We have a character mesh component, which has the character's arms. And then we have a simple capsule component, which is the character's collision. So in here, we want to assign our character mesh to that custom character mesh that we imported, the character's arms. So I want to select this first person mesh component. And when it's selected in the details, we can set the skeletal mesh asset. So under this skeletal mesh asset, we can hit the drop down and we can select our sk underscore character mesh. And when we do that, you can see that the arms are all messed up. And that's just because we're playing that animation blueprint that we were using for that other character mesh. So under the anim class, just reset that to none. And you can see that it resets our arms to this T pose. But we actually want to set it to our animation blueprint player character, the one that we created. So in the anim class, hit the drop down and search for our animation blueprint underscore player character and select that like so. Now you can see that we have our arms over here, but it's facing the wrong direction. So all we have to do is press E to rotate it and rotate this 90 degrees, negative 90 degrees like so. And you can see that's facing the right direction, but now we just need to position it so we can see it in the first person camera point of view. So to move this up, we can just move it up like so. And to position this in the correct spot, what I'm going to do is select this, and in the details under the transform the location, I'm going to input some values, and you're free to just copy the values that I input. So just pause the video and copy the values because I got the perfect placement for the location. And so those are all the values that I did. Hit the compile and save button to save your changes. And now what we've done is we've added our character mesh in our character blueprint. And on that character mesh, we've added our animation blueprint assigned to our character's arms. So we can see that the idle animation is playing. And now we can actually test this out by going back to our first person map. And I'm going to close the content browser and hit the green play button. And now we have our character idle animation. So we have our idle animation, and if I start walking forward, you can see we have this walking animation, and if I stop, you can see that we go back to our idle animation. Now you can see it's very snappy the way that the animation is playing, and that has to do with our blend space, the blending between the animations in our blend space. So the way that we can tweak that is if we go to our content drawer here and go to our main animations, open up our blend space, idle, walk, run. In the asset details, you can scroll down until you see the sample smoothing section. Under the weight speed, we can increase this to a value of 10 or more, and that will adjust the smoothing. So now if we hit the play, you can see that it blends between those animations a lot better, and it's a lot less snappy than what we saw before. You can see that we have our idle, our walking, and we can't see our running animation because we haven't set up sprint yet. But as you can see, it's blending between those two different animations. So now that we have our simple character animation set up and we can see our character's hands, what we want to set up is we want to give our character a simple weapon that we can see in our character's arms. So you want to go ahead and open up the Epic Games launcher and head over to the Marketplace tab and search for military and filter by free. And we can see that we have these military weapons. So we have military weapon silver, military weapon dark. I'm going to select this military weapons dark. And in here we have a couple different weapons that we can use. So we want to click on add to project and again show all projects and search for our FPS game tutorial. Select the project. It's going to ask us to select the closest alternative version. Again, just hit the drop down and select the closest alternative version, which is 4.27, and just click add to project. So once that's done downloading, we can go into our content drawer, and in here we should have a folder for military weapon dark, and in there we have a folder named weapons, and you see all the weapon meshes that we get. Now we want to attach this assault rifle to our character's hands. So the way that we can do that is go to our character mesh. So we want to go to our main animations and find our SK character and double click and open this up. So this will pull up our character's arms, and we actually want to head over to the skeleton. So to head over to the skeleton, you can click on the skeleton icon over here. So you see the skeleton, click on that, it will open up the SK character skeleton. Now in the skeleton, you'll see that we have all the different bones that make up our character's skeleton. So when I select a bone, you can see that I will highlight that bone. I have the lower arm bone selected, the hand bone selected, but basically we want to add a socket or a location that we can attach our weapon to our character's skeleton. So to do that, we want to actually preview an animation. So over here we have this preview animation button. So hit the drop down. We want to search for our rifle idle animation. So select that. What you'll notice is it now plays this rifle idle animation, and to pause this animation, you can just take this little timeline scrubber and put it as 0, and that will pause the animation. But now we should be able to attach our rifle to our character's hand. So in order to do that, we want to select the hand R bone, the right hand bone, and onto that hand R bone, we want to right click and add a socket. Click on the add socket. So sockets are what allow you to attach different weapons, tools, items, various different things to your character mesh just by the use of sockets. So now that we've added this socket, we can actually double click on this to rename it and just rename it to our weapon socket. Then onto that socket, we can add our actual weapon. So if you right click, we can add a preview asset and we can add that assault rifle _B. Now we'll add that weapon to our character's weapon socket. Now all we have to do is rotate it. So press E to rotate. So we can rotate it up, over, press W to move, and we can move it. And basically we just want to position this rifle in our character's hand. Now what you'll notice is the rotation is really snappy. We can't get a perfect placement, so we can turn off the rotation snapping by clicking on this blue icon. And now you can see we can actually select the weapon socket and rotate this at any rotation that we'd like. You can also turn off the movement snapping by turning off this grid icon, and that will allow us to position it exactly where we'd like it. Now I'm going to again input some values. So if you select this weapon socket in the details, I'm going to input a location and rotation value. So again, you're free to pause the video and just copy the exact values that I have to get the perfect placement. So these are my values. You guys can pause the video and just copy it. So I have my location and my rotation, and this will give me the perfect placement. But again, you guys can just pause the video and copy these values. This is just what worked best for the animations, also for the aim animations. So just copy the values that you see on the screen, and then just click save and close out of there. And we can actually close out of our characters mesh and our idle walk blend space. And now you want to go ahead and open up your BP first person character, because in here we want to add our character weapon mesh to our socket. So in the viewport, you want to select our character mesh, and under the components, we want to click on this add icon, this plus icon. Click on that, and you want to search for a skeletal mesh component. You want to select on the skeletal mesh component, and that will add it onto our first person mesh. So now we have a skeletal mesh under our first person mesh. I actually want to right click and rename this to our weapon mesh. Then with that weapon mesh selected, in the details, we can set the skeletal mesh asset. So if you hit the drop down, we want to set this to our assault rifle B. And now you can see that we've added our assault rifle in our character blueprint. Now we just need to attach it to our weapon socket. So since this weapon mesh is a child of our first person mesh, since it's below the character mesh, we can actually attach and select a socket that we want to attach this to. So in the details, with the weapon mesh selected, we can, under the parent socket, hit the drop down and assign this to our weapon socket. Now if we zoom out, you can see that it adds it all the way up here, and that's because we need to reset our location and rotation values. So under the location, we can reset, hit on the reset arrow, and reset it all to 0. And now you can see it attaches it perfectly at our weapon socket location, which is perfectly attached to our character's arms. So now let's hit the compile and save button. And if we go to our first person map and hit the green play button, you can see that we now have our weapon mesh attached to our character's hand. So now that we have our character's weapon mesh attached to our hands, we're going to go ahead and start setting up all of the other logic for our character. Things like our aiming, our firing, sprinting, and much more. Now before we get started, let's actually delete this pickup rifle because this will actually cause problems with our character blueprint. So just delete that. We don't need that. And let's close our character blueprint and our animation blueprint. And in our first person blueprints, we're actually going to take this first person character blueprint and move it into our main folder. So in our underscore main, let's right click, create a new folder and name this blueprints. And into that blueprints folder, let's take our first person character and drag and drop it into our blueprints folder and click move here. And that should move it into our underscore main blueprints. So now we have our first person character blueprint inside of here. So in our first person character blueprint, if we double click, open this up, we want to head over to the event graph, because in the event graph, that's where we can add things like new inputs. We have our inputs, things like our input action look, input action move, and our input action jump. So we want to add a new input action for sprinting so that our character can sprint when we hold down the left shift button. So the way that we add a new input action is by creating a new input action in our content browser. And what you'll notice is in our first person folder, we have a folder named input. And in our input folder, we have our input mapping and our input actions. So we want to take these and actually drag and drop it into our underscore main just to keep things organized. So just go to your first person and take the input folder and drag and drop it into your underscore main and click move here. It's going to give us this warning message, source code config ini may need to find and replace for mobile controls. We'll just click OK, and that's fine. And now in our underscore main, we should have a folder for input. So open up the input, and in here we have a folder for actions. So open up the actions. And as you can see, we have already some of the inputs that we're using in our character blueprint, things like our input action jump, input action look, and move. So in our case, we want to add a new input action for our sprint. So right click, and to add a new input, you want to go to the input section and add a new input action. So that will allow us to add a new input action, which we can rename to our input action underscore sprint. So input action sprint. So now let's just save that, do a file, save all. And now to bind a key to our sprint, you want to go back to your input folder, and we have this input mapping context. file. So input mapping context default. You actually want to double click and open this up. And in here, we have this mappings. And if you expand this, you can see we have our jump, move, and look. And if you expand those, you can see that these are all mapped to keys. So for our jump, that's mapped to our spacebar key. Our movement key is mapped to our WASD keys. And our look is mapped to our mouse axis. So in here, we want to add a new mapping, and that will add a new mapping down here, which we can then assign to our input action sprint. And then if we expand that, we can assign that to a key. So in our case, we can assign this to our left shift for our sprint. So now our sprint is assigned to our left shift key. So save that. Now if we go back into our first person character blueprint, we can right click on the event graph and search for our input action underscore sprint. And that will allow us to add that input action event, just like what we have up here. So now we have our input action sprint. We can expand this, and we have all of the inputs, things like the triggered, started, ongoing, completed, or canceled. And in our case, we want to do the same exact thing that we're doing here for our jump. Basically, when it starts, we want to go ahead and sprint. And when it's completed, we want to stop sprinting. So the way that we can make our character move faster or make our character sprint is using and modifying our movement speed and our character movement component. So the character movement component allows us to adjust things like our character's movement speed. So to adjust that, we can just drag and drop this movement component on the graph so we can get it. And then off of there, we can set max walk speed to set the speed of our character. So select that, and we want to hook this up for the started. So if we hold down the sprint key, we want to set our max walk speed to 800 because that will be our sprinting speed. But then when it's completed, we want to set max walk speed back to our default value, which if we select our character movement speed and the details, if you scroll down, our max walk speed is set to 600 by the default. So we can reset our max walk speed back to 600 and just hook up the completed back to our set max walk speed. Then you can unexpand that so we just see the started and completed. And as you can see, we have our simple input action sprint. And when we hold down our sprint when it started, we'll set our max walk speed up to 800. When we let go of the sprint key when it's completed, we'll reset it back to 600. So if we drag and select all this and press C, that will add a comment. And we just name this to our simple sprint. And I usually like to click on the show bubble when zoomed. That way you can see what this comment says when you zoom out. But now we've added a very simple input action for our sprint, which changes our walk speed and makes us move faster. So let's hit the compile and save button and head back over to our first person map. And now if we hit the green play button, if I hold down shift, you can see that we're sprinting. If I let go of the shift, you can see that we're sort of walking. Now I'm actually going to adjust our movement speed because this is actually not our walk animation. This is our jogging animation. So the way that I'm going to do that is go back to your character, select our character movement speed, and in the details search for max walk speed. And I'm going to change this max walk speed down to 500 or 5 meters a second. Then in our sprint here, I'm going to change the max walk speed to 500 because that's the value for our walk animation. So let's hit play. And now you'll see that we have this walking animation playing when we walk. But if I hold down shift, you can see that we have the sprinting animation. And our character actually moves a lot faster when we sprint versus just normally walking. So now we have our simple sprint set up where our character is sprinting, and we have our walking, and then we have our idle. So now that we've set up our sprint, we want to also set up other things for our character, things like aiming. So to get started with our aim, we want to go to your content browser, _main, input, actions, and we want to add a new input action for aiming. So we want to right click and add a new input action, and name this to input action _aim. So now that we have that input action added, we can go ahead and go into our input mapping context. So you want to go to your input mapping context default. And in here, we want to add a new mapping for our aim. So under here, select our input action _aim and expand that. And in here, we want to map this to our right mouse button. So hit the drop down and search for our right mouse button. And now we have our input action bound to our right mouse button. So now let's close that, and in our first person character blueprint in the event graph, underneath our sprint, we can right click and search for that input action _aim. So we have our input action aim, and let's expand this. And the same exact thing, when we hold down the aim on our right mouse button, that will call this started. When we let go of our aim, that will call this completed. So the way that we'll handle our aiming is by setting a Boolean in our character to say that our character is now aiming, which will allow us to transition between our idle animation and our aim animation. So we'll need to, in the variables over here, click on this plus icon to add a new variable and rename that to isAiming ? And then you want to go ahead and select that variable, compile and save. And this is set automatically to a Boolean, which is a true or false. And so isAiming is by default is set to false. So we just want to get this and set this on the graph. So when we start aiming, that will set it to true. But if we stop aiming, we want to, off of the completed, if we stop holding down our input action aim, we want to set that back to false. So we can unexpand that. And now we have a very simple aim logic. Now we just want to basically take this Boolean and use it in our animation blueprint to determine what animation should we be playing if we are aiming, because we have some aim animations. So the way that we'll do that is through an interface. So in order to get this variable from our character in our animation blueprint, we'll need to add a blueprint interface to retrieve this Boolean variable. So if you've never messed around with interfaces, I have a full detailed video explaining what our blueprint interface is in my Blueprint for Advanced Users tutorial. So if you want to get more in depth about blueprint interfaces, go watch that video. But essentially, blueprint interfaces allow you to pass or retrieve variables from one blueprint to another. So it allows you to communicate different variables from one blueprint to another. So in our case, we want to pass this Boolean isAiming from our character blueprint to our animation blueprint through the use of our interface. So in our main folder, blueprints, we want to right click and create a new folder and name this to interfaces, and then double click, open that up. And in here, we want to add a new blueprint interface. So to add that, you want to right click, and under the blueprint, we want to add a new blueprint interface. So select that. It's going to ask us to name it. We'll name this to BPI for blueprint interface underscore player character. So this will be our player character blueprint interface. So double click, open this up. In here, we have a simple graph and we have different functions that we can add. So we just want to add a simple function that will retrieve our isAiming Boolean. So we can rename this to get isAiming ? Basically, it's just getting our isAiming Boolean. Then to retrieve that, we want to add an output down here. So click on the plus icon to add an output, and we want to output a Boolean, the same variable type, and we want to rename this output to isAiming ? And then hit the compile and save. So basically all that this function does is going to retrieve that Boolean and output the isAiming. So now to add this interface to our character, you want to head over to your character blueprint and head over to the class settings. Click on the class settings button. And in the details, we have this section for interfaces, implemented interfaces, and we can hit the drop down to add our new BPI underscore player character interface. So once you add that, you can now see that we've added that BPI character interface. And in the blueprint section down here under the interfaces, we have that new interface function, the get isAiming. So you just have to double click to add that function or to open it up. And you can see that we can now return that isAiming Boolean variable. So we can take this variable in our character and plug that in for our isAiming. And now we have a function that will retrieve the value of our isAiming. So hit compile and save. Now to close out of this function, you can click on the close icon, and that will close out of that and bring us back to the event graph. So now all we have to do is call that interface in our animation blueprint to retrieve the value of this isAiming. So let's go to our main animations, open up our ABP player character, and let's head over to the event graph. And over here in the event graph, we have a reference to our character. So this try get pawn owner. So off of there, we can actually drag off here and call that interface get isAiming. And you can see we can call that interface function our BPI player character get isAiming message. So select that. We're calling that function that we created, and it's returning that Boolean value isAiming. So now we can hook up the execution and just take this Boolean value and drop it on the graph and promote that to a variable named isAiming. So just click anywhere on the graph and click compile and save. And now we are saving that isAiming to a variable in our animation blueprint, which we can then use to determine whether or not we should blend between an aim animation or our idle animation. So to blend between those animations, we want to head over to our state machine. So let's go to our state machine, go to our idle walk run state. And in here, we have our idle walk run blend space. We actually want to blend between our aim idle in our idle walk one blend space. So the way that we can do that is by blending our poses by Boolean. So if you drag off this animation pose, we can search for the blend poses by Boolean. We have this blend poses by Boolean node. So if you add that, you can see we have a true and false, and then we have a Boolean value to determine what pose should we pick based on our Boolean. So let's actually unhook that by holding Alt and clicking. So for our active value, this will be our Boolean, our is aiming. So drag that on the graph and get it, and plug that in for the value. Now if we are aiming, if that is true, we want to hook up our aim idle animation. So we have our rifle aim. So drag and drop that on the graph, and that will add that rifle aim animation. We'll plug that in for the true. Now if we are not aiming, if this is set to false, we can just plug in our idle walk run blend space. So just hit compile and save. Now if this is set to true, it will call our rifle aim. And we actually want to select this animation and make sure that we set in the details, set this to loop animation. So hit the compile and save. So now what we're doing is in our character blueprint, when I hold down the right mouse button, it will set our aiming to true. And in our character animation blueprint, it's going to get our is aiming Boolean. And whenever we modify it, it will update that value. And in our state machine, basically it will choose what animation should be playing based on that is aiming Boolean. So now we should be able to actually test this out. So if we go to our first person map and hit play, if I hold down my right mouse button, you can see that we are actually now aiming by holding down the right mouse button. We're playing that aim animation. So we have our simple aim set up, but what you'll notice right now is currently it's not lined up perfectly and it's actually clipping through our gun. So we can fix that in two different ways. The first thing to fix the clipping is you want to go to your edit project settings, and in here you want to search for near clip. So we can adjust the near clip plane, which is the distance of the camera's clipping to an object in front of the camera. So I'm going to adjust this down to 5, and in order to see that take effect, you have to restart your project. So just go ahead and close and reopen your project. And also what I like to do is I like to open up my content browser, leave that dock, and I like to actually, instead of hitting this green play button over here, playing it in the viewport, I like to hit the 3 drop down button icon and click this new play in new editor window. So that will play it in a new editor window. But what you'll notice is when I hold on the right mouse button, our clipping is not nearly as bad as it was before. It's still clipping a little bit down there on the bottom, but we're going to fix that by rotating this gun. So currently you can see that's not perfectly lined up. Our gun is still not perfectly lined up in the center there. And the way that we'll fix that is through our character blueprint. So open up your character blueprint, head over to the viewport, and we actually need to adjust the character arms positioning. So to get the perfect positioning, you want to get the same exact values that I have here for the location, and also for the rotation, you want to set the rotation values to this -87.73. So you just want to make sure that you have the same exact values that you have here. So again, just pause the video. This will give you the perfect placement. But if you have those values, compile and save and hit play, you can see that our gun is perfectly lined up in the center. So it's perfectly positioned in the center, and when I click on my right mouse button, it's perfectly centered up like so. So I just got those values by messing around with the positioning, by rotating it and positioning it perfectly so that it can line up perfectly in the center. Now for our aim in our character, if we head over to the event graph, currently we're just setting this aim a Boolean to true or false. What we also want to do is we want to make our character movement slow so that when we aim, our character will move slower. So the way that we'll do that is we're going to set our max walk speed, much like we're doing up here for our sprint. We're going to get our character movement, and if we're aiming, we want to set our max walk speed down to a speed of 300 to slow down our speed. Now if we are not aiming, we want to reset and set our max walk speed back to our original speed, which is 500, just like so. And that will just slow down our character movement. And the other thing that we want to do is we want to set our field of view of our camera so that it will zoom in. So the way that we can set our field of view is by getting our camera component. So you get your camera component, and we can do a set field of view. And we can set this field of view value to 70 and take our camera and also set the field of view back to the default value, which is if you select your character camera component, and you see the current field of view, the default value is 90. So we'll reset that back to 90. So hit compile and save, hit play. You can see that it has sort of the zoom effect. So when you set the field of view lower, it will zoom in. If you reset it, it goes back to our normal 90 value for field of view. Now, if you want to add a lot more of a smoother transition, instead of having it just snap instantly to that field of view, what we can do is we can add a timeline that will smooth transition between our value of 90 down to 70. So to add that timeline, let's actually delete this, unhook this, and right click and add a timeline node. So we can add a timeline, and let's rename this timeline to aim timeline. And then to open up this timeline, let's double click and open this up. And in here we can add a new track. So click this track icon, and we want to add a new float track. So basically this will give us sort of a graph where we can add two different points to blend between those two different points, or those two different values. So right click anywhere on the graph and add a key, which will add a point on the graph. Then with that point selected, we can set the time and the value. So we want to set our time to 0 and our value to 90, and then click anywhere else on the graph to add another key, select that key, and we want to set the time to 0.2 and the value to 70. Then you want to click on the zoom fit horizontal, zoom fit vertical to see those 2 points on the graph. Now we want to make sure that this timeline stops at 0.2. So set the length to 0.2. So that will ensure that our graph will only play from our time value of 0.2 seconds. So now we have this value 1, which is value 90, that goes all the way down to value 70 in 0.2 seconds. So compile, save, and close out of that timeline, and now you can see that we're outputting that value. So basically when this timeline plays, it will start from value 90 and it'll go all the way down to value 70. So all we have to do is, for the update, hook up the set field of view, and then for this new track, we can plug it into our field of view. So then when we click aim, what we want to do is play this from the start, which will play our timeline from the start, which is our value is 90, all the way down to 70, and that will output a smooth transition for that value. Then if we want to do the opposite, meaning if we stop aiming, we want to reverse from end this timeline, and that will go ahead and reverse that from the end, which will start from 70 and go all the way back up to 90. So now if everything works correctly, let's go ahead and compile, save, and hit play. You can see that we have this zoom transition. It will zoom in and out, and it will be a smooth transition between our value of 70 for our field of view to our value of 90. So that is our very simple aim logic. The next thing that we want to set up is we want to give the character the ability to fire its weapon, so that when we left click, it will go ahead and fire our rifle. So the first thing that we'll need to do is first add a new input. So go to your main input, under the actions, let's right click and add a new input action. But we actually already have an input action in here for our shoot. So we can actually just use this input action shoot. If we double click and open this up, it already has a trigger. So we have this triggered pressed. We actually want to remove this trigger because we want this input action to be held down and not pressed. Because if you add a press trigger, that will allow you to press this once, and we don't want that. We want the player the ability to hold down the mouse button. That way they can automatically fire the rifle, and we don't want it to be a semi-automatic where you have to press the key once each time to fire. So let's remove this trigger by clicking this trash icon and deleting that. Save that. Close out of there, and let's go to our input mapping context default. Double click, open that up. And in here, let's add a new input mapping for our shoot. So click on the plus icon to add a new input mapping and select our input action underscore shoot. And in that input action shoot, expand that and add a input for our left mouse button and save that. And so now our input action shoot is bound to our left mouse button. So now in our character, let's actually select our aim logic and add a comment for this. This will be our aim logic, and we'll just show bubble 1 zoom. But right below our aim logic, we can right click and search for our input action underscore shoot and add our input action for our shoot input. So for our shoot, we can expand this. We're going to use again the started and completed, because this will be toggled if we are holding down the left mouse button. So very similar to how we are holding down our right mouse button for our aim, we're going to do the same thing for our shoot. Now in our case, what we want to do is we want to have a automatic firing loop. So basically, if I hold down the left mouse button, I want to call a event that gets fired off every 0.1 seconds to basically fire off our firing logic to give it sort of a automatic rifle firing effect. So the way that we'll do that is by the use of timers. So timers allow you to loop an event over and over. So off of the started, we want to set a timer by event. So we can use the set timer by event, and that allows us to bind an event that we can loop. So drag up here to bind an event. You want to drag and drop it on the graph and search for the add custom event. So we want to add a custom event, and we'll rename this to fire weapon event. So we'll just hit the compile and save, and we want to set the time. The time will tell us how much we want to loop. So we're going to do 0.1 seconds. So every 0.1 seconds, this will loop. And of course, we want to hit the checkbox for looping. Then we're going to take this return value and promote that to a variable because we want to save a reference to this timer. And we can rename this to our fire timer reference. So we want to save a reference to the timer so that when we are done off this completed, we can stop the timer. So the way that we'll stop the timer is we can get that reference on the graph and do a clear and invalidate timer by handle. So hook this for the completed, and that will basically stop this timer. It will clear and invalidate the timer. So we can unexpand that, and now we've set up our simple shoot loop. So now for our fire weapon event, this is where we can hold all the different logic for our firing rifle. So the way that we're going to do this is first things first, we're going to play a firing animation. So we're going to play a firing animation on our character so that our character's arms will move back. And then we'll also play a firing animation on our weapon so that it will play a particle effect and it'll play a sound. So in the event graph off of this fire rifle event, we want to do a play montage. So we have this montage, play montage. And what the montage node will do is it will play an animation on to our character mesh. So to select our proper mesh to play this onto, we want to get our first person mesh and get that on the graph and plug that in for the in-skeletal mesh component. So that will be the skeletal mesh to play this montage animation onto. Then for the montage to play, we actually want to select an animation montage to play based on if we are aiming or if we are not aiming, because we want to play a different fire animation if we're aiming or if we're not aiming. So the way that we can do that is off this montage, we can do a select. So we have this utility select, and for the select, we want to give this first an index, basically which animation should we select based on what value. For that index, we can plug in our isAiming boolean. So just get that on the graph and plug that in for the index. So now you can see we have a true or false. So if we are aiming, we can play this aiming animation. If we're not aiming, we can play our not aiming animation. So now we just need to create some animation montages. So the way that we'll do that is in our content folder, main animations, we have a rifle fire, and we should also have a rifle aim fire animation. So to create montages of these are currently just animation sequence. We want to create animation montages so that we can play it on top of our character's animation blueprint. So we want to right click and select that animation and create an animation montage. So if you select that, that will add a new animation called an animation montage, which is color coded by this purple animation. So we created a fire rifle montage. We also want to create one for our aim fire. So right click that one and create an animation montage. So now we have a rifle aim fire montage and a rifle fire montage. Let's do a file save all. Now we can plug these in for our select. Let's go back to our character, and in our select we can plug in for the true. We want to hit the drop down and select our aim fire montage, because if we are aiming, we'll play the aim fire, but if we're not aiming, we'll just play the regular rifle fire montage. Let's compile and save. Now to actually see this in action, we need to modify our animation blueprint, because in order to play a montage on top of our animation blueprint, we need to add a special node inside of our animation blueprint. So let's go to our animations and open up our animation blueprint character, and let's back all the way out to our anim graph. So you should see the anim graph like so. And basically we need to add a node in between our state machine and the output to basically hijack the animation or to interrupt the animation that's being played. And on top of that, play our animation montage. So the node that we're going to use is off of here. We can call the default slot. We can add this montage default slot. And what that will do is it will basically interrupt the current animation that's being played to play on top of that our animation montage. So now let's hit compile and save. And because we've added that slot, we can now play montages on top of our animation blueprint. So now what we should do is when we hold down the shoot, we should see our firing montages be played based on if we're aiming or if we're not aiming. So let's go ahead and test this out by hitting play. So if I hold down the left mouse button, what you're going to notice is it's very subtle. If I scope in, you can see that it's playing this fire montage, you can see that the character's mesh is moving back a little bit. And we actually need to modify the play rate for our firing animation. So go back to your character, and in the montage, we can adjust the play rate. So we're going to adjust this down to 0.8, hit compile and save. And we should notice the animation a little bit more. So in the aim, if we aim, you can see that it's firing. You can see that our gun moves back every time we click. If we hold it down, you can see that it's sort of jittering. And that is our firing animation. Again, it's very subtle. You can't really notice it that well. And to adjust that even more, we could adjust the play rate of the animation. And so if we go to our animations, say we open up our rifle fire montage, we can adjust the rate scale to say 0.5, and you can see what the firing looks like. So let's save that. Let's hit play, and now you can see that we have the fire montage. It's a lot more noticeable if we change the rate scale. But that is basically what our fire montage animation looks like. So now we want to add a muzzle flash for our gun so that it looks like we're firing our gun. And so in order to do that, we can play an animation on our gun. And we already have some animations that come included with these weapons. So we go to the military weapon dark, weapons. We have a folder for anims, and we have a firing animation for our rifle. So if you go to the rifle, we should have a rifle fire. So we have this fire rifle _ W. If you double click open that up, you can see that we already have this firing animation set up that has this muzzle flash and has this sound playing. So we can actually just play that animation by going to our character blueprint, and over here off of our play montage, right over here, we can get our weapon mesh, and then off of there call the play animation node. And since we don't have an animation blueprint for our weapon mesh, we can just call the play animation node rather than the play montage node. And in this case, we can select our animation to play. We can search for that fire _ rifle _ W and just compile and save. And now we're calling that play animation node to play the rifle fire on our weapon mesh. So now let's go ahead and hit play. And if I fire, you can see that it's playing this fire particle effect. It's also playing a sound, and we can also scope in. You can see that's playing the same fire animation as well. So now we have our basic firing logic, which is just playing a simple firing particle effect and animation on our character. So now what we want to set up is we need to give the character the ability to do a line trace so that when we fire our rifle, it will do a line trace from our camera's position, and it will check and see if we hit something. Because if we hit something, we want to apply some damage and also play a hit particle effect wherever we hit. And later on, we'll add things like bullet holes to wherever we hit an object. So the way that we'll add that is in our character blueprint off of our fire rifle logic over here. So when we click our shoot, we do our looping event. Off of our play animation, we want to add a function that will contain our firing logic. If you've never used functions before, basically it's sort of like a collapsed graph. It allows you to contain all the blueprint logic inside of it and recall that function as many times as you would like. So under the functions, we're going to create a new function and name this to shoot function. Compile and save, and head back to the event graph, and off of our play animation we can call that shoot function on the graph by just drag and dropping it on the graph and calling it like so. And let's add a comment for all of this because this is our shoot logic. So just rename this to shoot logic for our character's weapon. So compile and save. So now we can go into that shoot function, and into here we want to do some logic like a simple line trace from our center of our camera's position to basically check and see if we hit something. So to do our line trace, we want to do it from our camera's position. So we want to get our first person camera component because we need to get the location of the camera as well as the rotation for our line trace function. So off of our camera, we want to get the world location of our camera, and then we also want to get the world rotation of our camera. Then to do our line trace, we want to, off of our execution, call the line trace by channel node. So for the start position, we want to get our world location of our camera. Then for our end location, we need to do a little bit of calculation to determine where the end of our trace should be. So off of the end, we want to do a add. And basically, we want to use the add operator because we want to add our starting location plus a little bit of math to calculate our end location. So to get our end location, what we'll do is we'll get the rotation of our camera, then we'll get the forward vector of that rotation, and that will give us this yellow vector. Then with that, we can multiply this. we can multiply that by a float. So we want to actually add a new variable and name this to bullet distance. And then we want to change this value to a float because this will be the distance of our bullet. So compile and save. And now that we've compiled that, we can set a default value for our bullet distance. So in our case, I'm going to set this to 10,000, compile and save, and then get that bullet distance and plug that in for the multiply. So that will multiply our camera's forward vector by that bullet distance. And then we can add that with our start location. So that will basically calculate our end location. At what point should we start our line trace and what point should we end our line trace? Then we want to change the trace channel to our camera because we're doing it from our camera location. We also want to trace complex, so we can trace complex collision. And just to visualize this, what we can do is under the draw debug type, we can do a for duration. That way we can see our line trace. So let's compile and save, and let's actually play test this out. So let's go ahead and hit play. So if I hold down my left mouse button, you can see that we're firing these line traces from the center of our camera's position. So if I hold down the left mouse button, you can see wherever I look, we're firing this line trace. And if we hit something, it will add that red box. If I shoot into the air, you see we're not hitting anything. But if I shoot this wall, you can see wherever I hit, it's marked by that red box. So now with the hit location, what we can do is we can play hit particle effects if we hit something, and we can also put bullet holes wherever we hit. So let's go back to our first person character in our shoot function. And off of this line trace, it gives us a return value if we actually hit something. So off the return value, we can do a branch. If we actually hit something, the two will get called. And then off of this out hit, if we drag off there and break the hit result, this will give us a lot of information about where our line trace hit. Basically, it'll give us the location of where we hit. If we hit an actor, it will give us the actor that we hit. And we can use all this information to spawn a particle effect at our hit location. So to spawn a particle effect off of the true, we can call our spawn emitter at location node. And that will spawn an emitter at the location at our impact point. So just take your impact point and plug that in for the location. And then for your emitter, we can hit the drop down, and we already have some particle effects that come included in our military weapon pack. So just search for P_impact, and we have this P impact metal medium. I'm going to use the P impact metal medium. Then we also want to adjust the rotation so that's facing the normal of what we hit. So off the impact normal, we can get the rotation from X vector, and that will allow us to get the rotation, what rotation we should play this impact particle effect based on wherever we hit it. So compile and save. Let's go ahead and hit play. And if I shoot my rifle, you can see at the hit location, we're playing this hit particle effect, and it's properly rotating the particle effect and spawning it at the hit location. So if we want, we can actually remove our line trace. So if we go to our first person character and set our debug type to none, that will remove that line trace so we can only see the particle effect. So you can see we have this little hit effect basically wherever I shoot. So we're spawning a simple particle effect. Let's say we also want to add things like a bullet hole wherever we hit an object. So to add a simple bullet hole decal, we'll actually need to import a texture for our bullet hole. So you want to head over to the project files on my Patreon, and with the project files downloaded, you want to go to the widgets, and in here we have some simple textures. We have this bullet hole.png. So let's go to our content main and create a new folder for textures. And just double click, open that up, and drag in this bullet hole into our project. Then with that imported, we want to right click and create a new material to create a material for our decal, and name this to m_bullet hole, and do a file, save all. Then we need to open up this material because we need to set up the decal material. So in order to set up a decal material, you want to select this material node, and in the details, we want to set the material domain to a deferred decal. And then we want to set the blend mode from opaque to translucent. And then we want to take this texture, the bullet hole texture, and drag and drop it into our material and plug in the RGB into the base color. And then we need to tell it what to mask. So for the mask, we just need to get this alpha and plug that in for the opacity. And that will go ahead and mask our bullet hole. So just click save. That's all we need to do for our decal. We can close out of there. And now let's go to our first person character. And in our shoot function, we just need to spawn that decal wherever we hit something. So off of this execution, let's call the spawn decal at location node. For our decal, we can select our m_bullet hole material that we just created. For the decal size, we can specify how big we want this to be. I'm going to set this to 8 by 8 by 8. Then for the location, we can choose where we want this decal to be spawned at. In our case, we want to choose this location. So this location right here. Choose that for the location. And then for the rotation, we want this to be rotated proper direction. So again, we want to get the rotation from X vector and plug that in for the rotation. Then for the lifespan, this will be how long this decal will be shown before it is deleted. We want to give this a lifespan at least 1 or greater. In my case, I set this to 5 seconds. That way it will be shown for 5 seconds before it's deleted from the level. So now let's go ahead and hit play and test this out. So if I shoot something, you can see that we've added these bullet holes. And one thing you'll notice is if I shoot these bullet holes after 5 seconds, they will fade away. So you can see they all despawn. But if we actually walk away from these bullet holes, you can see that they fade away and you can't see them at a certain distance. So in order to see these bullet hole decals from far away, we'll need to enter in a special command to adjust at what distance should we see decals at. So if you press the tilde key on your keyboard, that will bring up the console up here. And you want to type in here r.decal.fade screen size multiplier space 30. And I'll put this in the description of the video. But basically, if you press enter and if we walk away, you can see that we can see these bullet hole decals from farther away. And that will basically set in our project the distance of which we should still be able to see these decals. So you can see no matter how far away we can still see the bullet hole decals. So now we have our simple hit effects and bullet holes. What we're going to add next is we want to add a little crosshair on the center of our camera. That way we can see where we're shooting and the character can see basically a little crosshair to help them aim at the target. So in order to add a crosshair, we'll need to add a main HUD widget. So if you never messed around with widgets before, this will be a very brief introduction. So in our main folder, we want to right click and create a new folder and name this to widgets. And then double click and open this up. And in here, we're going to right click and create a new user interface widget blueprint. It's going to ask us to pick a parent class. We just want to select this user widget. Then we want to go ahead and rename this to our w_main HUD. Let's do a file save all. And then let's double click and open up this widget. So basically in this widget, this is a simple graph that will be our screen. And we can add different types of things like images, buttons onto our screen. That will be our user interface. So the first thing that we need to add inside of here is a canvas panel or a canvas on which we can start working on. So in the palette, you want to search for canvas. And so we have this canvas panel and you want to drag and drop this onto your main HUD. And that will add this canvas or this rectangle that you can sort of visualize as the player's screen, which we can start adding things like buttons, images, sliders, text, anything that we'd like onto our main HUD. Now what we want to add is we want to actually add a dynamic crosshair in the center of our camera's position. So the way that we'll add this dynamic crosshair is by adding a couple of borders onto our screen. So you want to, under the palette, select the border. So under the common border, drag this border onto the graph, and you can see that it adds sort of this white image. So if we scale this down, this will basically be our crosshair. So we want to select that border. And we actually want to change the anchor, which is this little flower icon over here. We want to anchor this to the center of our screen. So you want to choose this center anchor, and that will anchor it to the center of our screen. Now with that selected, we actually want to set our position X to 0, position Y to 0. We want to set all the values of this to 0. So it should be all set to 0 like so. Then under our padding over here, we want to set this value to 2. Then let's hit compile and save. And then with this border selected, we actually want to give this a tint. So under the brush color, we can change this to a black tint like so. And that will change the brush color. And then we can add another border onto this border, onto it like so. And all we have to do in here is change the padding. So this padding right now is set to 4. We want to reset that down to 0, like so. And so we should have these two borders. We have this border on top, which is brush color set to black. and this border on the bottom, which is set to white for the brush color. So compile, save. Select this top border and rename this border to top crosshair. Set that to a variable. And then we want to copy and paste that on our canvas panel and rename that one to our bottom crosshair. And then take that and copy and paste it again on the canvas panel and rename this to left crosshair. And then paste it one last time and rename this to right crosshair. So now we should have that same exact border copy and pasted 4 times. So we have a top crosshair, bottom, left, and right. And they're all set to variables. So because they're set to variables, we can use that in the event graph to set up our crosshair. So you want to head over to this graph by clicking the graph icon, and that will pull up the event graph where we can actually program in the logic behind our crosshair. So in the event graph, we want to delete everything other than the event tick because we're going to use the event tick. So in here, we want to set up is our crosshair because we need to set the position and scale based on our size. So the way that we're actually going to do that is we'll actually do this off the event construct. So right click and search for the event construct. And we're going to get all of our crosshairs. So get our bottom crosshair, get our left crosshair, get our right crosshair, and get our top crosshair. And then we want to get each of these as slot as canvas slot. So we want to get that slot as a canvas slot. And then we want to do the set size. So we want to do the set size. And for the insize, we want to right click and split the structure and hook this up like so. Now for this first one, we just want to set the bottom and the top crosshair. So get the bottom and plug that in for the set size, but also copy this slot as canvas slot and plug that in for the set size for our top crosshair as well. And for the insize X and insize Y, we want to create 2 new float variables. So in the variables, we'll create a new variable and name this to crosshair thickness, and we'll change this to a float. And this will be how thick our crosshair will be. So in the default value, we can set our default value of 8 for the thickness, and then add a new variable and name this to crosshair length, and that will be how long the crosshair will be. So compile and save, and we'll give this a default value of 20, and then we can plug this in and get these both on the graph. So for the thickness, that will be in the size X, and for the length, that will be in the size Y. Now for the left and right crosshair, we're going to do the same exact thing. So we can actually just copy and paste the set size and plug it in like so. And we want to set the size of our left and right crosshair. So plug that in like so. But for the size X and Y, this will actually be flipped from our thickness and length. So we want to get our thickness and length on the graph. But for the size X, that will be our length, crosshair length. And for the size Y, that will be our crosshair thickness. So just plug it in like so and hit compile and save. And that will set the size of our crosshair. Now off of the event tick, we want to set the position of our crosshair. So the position will be based on the crosshair type. So for example, our top crosshair will be on the top, bottom one will be on the bottom, left will be on the left, and right will be on the right. But if our character moves forward, we want to spread out our crosshair. And if they stop moving, we want to shrink the crosshair so that's center up in the screen. So the way that we'll set up that dynamic crosshair is off of this event tick. We want to first right click, get our player character, get a reference to our player character. Then off of that reference, we want to get the velocity of our character. So we have this transformation get velocity. And then from that velocity, we can get the vector length of that velocity. That will return this value, which is this float. Then from that float, we need to do a map range. We need to call this map range clamped. So this max range clamp we're going to use to set the spread of our crosshair. So we need to set the max range or the max spread that the crosshair can be, so that it's not stretching across the entire screen. So for the in-range B, we're going to set this to 450. For the outrange A, we'll set this to 5. And then the outrange B, this will be set to 70. And these again are just values that we played around with. And you can test these values out to change the max spread of the crosshair. We want to take this return value and promote this to a variable and name this to spread. So that would be the crosshair spread. So hook that up for the event tick. So now down here on the event tick, we need to set the spread of our crosshair as well as the position based on each individual crosshair's position in the viewport. So the way that we're going to do that is first we're going to set our bottom crosshair. So let's get our bottom crosshair on the graph, and we want to get the slot as a canvas slot. And then from there we can set position of that canvas slot. So let's hook up the execution. For the in position, we need to right click and split the structure, and we're going to do a little bit of math to determine the X and Y position in our viewport. So first we're going to get our crosshair thickness and then divide that and then add in a subtract node. So divide this value by 2 and then subtract 0 from our crosshair thickness and then plug that in for the position X. For the position Y, we want to get our length, crosshair length, and subtract that by our crosshair length as well. And also we want to do a add this with our spread. So get our spread and add that and plug that in for our position Y. Then for our top crosshair, we want to get our top crosshair and get the slot as a canvas slot. And also we want to set the position of that. So hook up the execution. For the in position, let's right click and split that structure because we need to set the position X and Y based on a little bit of math. So again, we want to get the crosshair thickness and divide that by a value of 2. Then let's add a subtract node and subtract our thickness by 0 and plug that in for the X. Then we want to get the crosshair length and subtract that. Actually move this pin by holding down Alt and subtract 0 by a crosshair length and subtract that by our spread variable. So plug that in like so and plug that in for the position Y. So we have our top and bottom crosshair. Now we need to set the left and right. So let's get our left crosshair and do a slot as canvas slot. And then off of there, we can again do the set position node and hook up our execution. We can right click this and split the structure because we need to set the position X and Y. So for the position X, we need to get our length, crosshair length, and do a subtract. So subtract our crosshair length by 0 and then subtract that value by our spread and plug that in for the position X. For the position Y, we want to get our thickness, crosshair thickness, and divide that by a value of 2. And then we're going to subtract this. So copy our subtract that by 0 and plug that in for our position Y. Lastly, we want to get our right crosshair and get the slot as a canvas slot. And again, also do a set position. So let's hook up our execution, right click the structures to split that. And for our position X, we want to get the length of our crosshair and add that by our crosshair spread. And then we want to subtract that by our length, crosshair length, and plug that in for our position X. Then for our position Y, we want to get our thickness and get that on the graph and divide that by a value of 2. And then subtract this by a value of 0 and plug that in for our position Y. So now we have our dynamic crosshair set up. We're setting our left, right, top, and bottom crosshair position based on our character's velocity, which will set the spread. The thickness and length values are set. We set the default for a default thickness to 8, default length to 20. So you guys can play around with these values. But now all we need to do in order to see this crosshair on our screen is we need to add this main HUD widget and create it in our character blueprint. So you want to head over to your character, first person character, head over to the event graph, and on the event graph, we want to right click and add a event begin play. So we have this event begin play. So this event will get called when the player plays the game. So off of this event begin play, we want to call the create widget node to create our main HUD widget. So we want to, under the class, select our main HUD widget. For the owning player, we want to drag up here and get our player controller. And then that will create the widget. Now we just need to add it to our screen. So before we do that, we actually want to take this and promote this to a variable. That way we can save a reference to this. And we'll name this to our main HUD reference. And then lastly, we can add it to our screen. So in order to add it to the screen, you drag up here and do a add to viewport. So viewport, add to viewport. And now we'll go ahead and add it to our player screen. So then just select all this and add a comment. This will be event begin play, create our main HUD widget. And we'll click show bubble when zoomed. So now let's go ahead and play test this out by going to our level and hitting play. And now you can see that we have our crosshair widget on our screen. If I strafe left or right, you can see that the crosshair spreads out. If I stop moving, it collapses back in. And you can see as long as our character is moving, the crosshair is spread out. But if I stop moving, it is collapsed in. Now, one thing that I want to remove is when I actually scope in like this, I want to remove the crosshair. So I want to hide the crosshair when I scope in because we're using the iron sights of the gun instead of the crosshair. Crosshair really is only for when we are not aiming. So the way that we can add that is we can go to our main HUD, and inside of our main HUD, what we can do is right click down here and add a custom event. So search for add custom event. And we can just rename this to hide or show crosshair. Then to hide or show our crosshair, we can get our bottom crosshair, our left crosshair, our right crosshair, and our top crosshair. And off of here, we can set the visibility. We can do this widget set visibility and set this to basically whatever we want it to. So we can actually take this visibility and plug this into our custom event to add that as a input. And then we can hook up the execution, and let's hook up all the targets because we want all of them to be hidden at the same time. And then hit compile and save. And now we can call this custom event from inside of our character blueprint and set the visibility of these widgets of our crosshair based on if we want to hide it or show it. So in order to call this custom event, all we have to do is go to our first person character blueprint, and we'll call it off of our aim logic because when we scope in is when we want to hide it, and when we scope out, we want to re-show it. So we'll actually move this timeline over like so, and in order to call that function, we need a reference to our main HUD. So luckily we have that reference down here. So we can just drag that reference, get it on the graph, and call that show or hide crosshair function. So call that, and now we can just hook up the execution for our player and start, and we want to set that to hidden when we're aiming, but we also want to call that same event show hide or show crosshair because we want to plug this in for the reverse from end, and we want to set that back to visible when we're done aiming. So we're going to hide the crosshair when we're aiming. We're going to re-show it to make it visible when we are finished aiming. So now that we've set that, that will set the visibility of those crosshairs in our widget. So now if we hit play, if I scope in, you can see that the crosshair is hidden. If I scope out, you can see that our crosshair is shown. So that is our simple dynamic crosshair added through a widget on our screen. You guys can play around with things like the thickness and the length to adjust things like the crosshair appearance. So the next thing that we'll need to add to our game is we want to add some simple reload logic, because currently the character can just fire the weapon infinitely. They basically have infinite ammo. So we want to prevent that from happening by giving the character a base amount of ammo and a reload logic so that they can reload their weapon. So the way that we can implement that logic is we need to go to our first person character blueprint. And every time we fire our weapon, we need to keep track of how many bullets we have in order to make the player have to reload their weapon. So you want to go down to your shoot logic, and in our variables, we'll need to add a new variable named current ammo, and we'll need to change this from a float to an integer and compile and save. And we'll also need to add another variable named max ammo, and we'll also compile and save, and that is also set to an integer. Now for our current ammo, we're going to set the default value to 30, and for our max ammo, we're also going to set the default value to 30. So that will be 30 bullets in a clip. So currently the player has 30 bullets out of 30 bullets in their clip. So before we fire our weapon, before we call our animation montage, we want to do a check to see if we have enough bullets. So off of this fire weapon event, we want to get our current ammo and check and see if it is greater than 0. Because if so, we can fire our weapon. So off of here, we can do a branch and then just hook up this branch. So if our current ammo is greater than 0, we can fire our weapon, but if not, we're not going to do anything. So compile and save. Now, every time that we fire our weapon, we need to subtract 1 bullet from our current ammo value. So the way that we'll do that is inside of our shoot function. Let's double click open this up. Inside of our shoot function, right before our line trace, let's subtract that bullet amount. So we're going to get our current ammo on the graph and do a D increment
the increment integer. That will basically subtract one value from our ammo and set our current ammo to that. So let's go ahead and hook up our execution. And now to actually see this in action, we should be able to fire our weapon 30 times before it will not allow us to fire it anymore, because as long as our current ammo is greater than 0, we can continue firing our weapon. So if we play test this out by hitting play, hold down our left mouse button, we should be able to fire 30 bullets. And now you can see that we can no longer fire any more bullets because we've used all of our current ammo. Now to actually visualize this on our screen, to visualize how many bullets we have left, we're going to modify our main HUD widget so that we can see how many bullets our character has loaded into their gun. So let's go to our main widgets, and we'll actually need to import a little texture from the project files. So head over to the project files and go to the widgets. We have this rifle image. We want to select this and drag and drop it into our widgets folder, and double click open this up. We want to set the texture group from world to user interface or UI, since we're going to be using this in our user interface. So just close out of there. And the reason why we want to do that is just so that the engine knows that this is for our user interface, and it will compress it and have it set accordingly. So now we need to go to our main HUD widget. So double click open this up, and we want to head back over to the designer so we can add some images, some text for our ammo widget. So for our ammo widget, first in our palette, we're going to search for an image. We're going to drag this image onto our screen, and we can scale this up. And under the brush, under the appearance, if we expand the brush, we can set this image to a texture that we specify. In our case, I'm going to search for the rifle, this rifle texture that we imported, and we can scale this up like so. And basically we can move this down to the bottom right of our screen, and we want to change the anchor from the top left to this bottom right anchor. That way this image will be anchored to the bottom right of our screen. Now once we position this down here, we also want to add some text on top of here. So search for text and add a text onto our canvas panel and select that text. And again, we want to anchor it to the bottom right, like so. And you can move this over here. And then for the appearance, we can expand the font, and we can change the font type to light. And then we can also change the size of our font. So I set the font size to 49, and then you can change the content. So under the content text, we can set this to 30 out of 30 bullets. And let's scale this around like so. Let's move this up, and let's set the text aligned to the right, and that should be all set. So compile and save. Then select that text. We want to set that to a variable because we're going to need to modify the text value. So set that to a variable, and let's rename this text to our ammo text. So compile and save. Now if we actually play test this out, you can see that it's on our screen. We have our widget on our screen, but we need to bind our bullets to update the text whenever we fire our weapon. So in our main HUD, we want to head over to the graph. And again, what we'll need to do is add another event to update the ammo text. So right click, add a custom event, and name this to update ammo text. And on this event, we want to have two inputs. The first one will be an integer, and we're going to rename this to current ammo. Then add another value, which will also be integer, and that will be our max ammo. Compile and save. Then we want to set our text. So get our ammo text, get it on the graph, and do a set text. We want to do a widget set text down here at the very bottom, and hook up the execution. For the in text, we want to do a format. So off of here, do a format text. And for our format, we need to go ahead and type in squiggly brackets. So type in squiggly brackets current, then get out of that and do a slash squiggly brackets max. So if you type it exactly like what I've shown on the screen, and if you press enter, you should see we have two inputs for the current and max value, and it will format it exactly like shown. So for the current, we want to get our current ammo and do a toText integer and plug in that return value into the current, and then just copy and paste this for our max value and plug that in for the max. So that will format our current and max ammo and put a slash in between it, and it will set our ammo text to that. So compile and save. Now we just need to call this event from inside of our character blueprint whenever we update our ammo text. So go to your first person character, and in our first person character, we only modify our ammo inside of our shoot function. So double click and open that up. So over here, we subtract one bullet from our current ammo. So to update our widget, we just want to get a reference to our main HUD. So get our main HUD reference and call that update ammo text event. And let's hook up our execution up here, that up to our line trace. And for our current and max ammo, all we need to do is plug in our current ammo variable, as well as our max ammo variable like so. So now we're just passing those variables to our widget, which we're then using to set the text on our screen, and we're updating it every time that we fire a bullet from our rifle. So let's go ahead and hit play. And now if I hold down the left mouse button, you can see that it's subtracting 1 of our current ammo. And now when I hit 0, you can see that I can no longer fire because we're out of ammo. We've reached 0 bullets out of 30. So now what we need to set up next is our reload logic, so that when I press the R key on my keyboard, it will reload and reset our bullets back to 30 out of 30. So to set up our reload logic, what we can do is let's go to our input actions, and we'll need to add a new input action for our reload. So in here, right click and create a new input action, and name this to input action underscore reload. For our input action reload, since this will be only called if we press on the R key, if we press it once, we want to double click open this input action up, and under the triggers we can add a new trigger for pressed, so that if we press on the reload key, it will call this input once. Okay, this is not like our right mouse button or left mouse button where we hold it down and we want it firing off. We only want this to be called once if we press this key. So we added this pressed trigger. So close out of there. Now you want to go to your input mapping context, double click open that up, and add a new mapping for our input action reload. So select our input action reload. So for our input action reload, we want to add our R key. So scroll down until you see the keyboard R. And now we've successfully mapped our reload to our R key. So now let's go to our first person character. Let's head over to the event graph, and right below our event begin play, we can right click and search for that input action underscore reload and add that input action event. And since we only set this trigger to whenever we press the input, we can just use this triggered node, because we're not going to be holding it down like what we do for our shoot or for our aim. We're just going to be calling this once. So whenever we trigger this input action, we can call our reload logic. So for our reload logic, this will actually be really simple. We're just going to play a reload animation. So to play a reload animation, we're going to first get our character mesh, our first person character mesh, and call the play montage node, because we want to play an animation montage. So hook up the execution to the triggered, and for the montage to play, we need to choose a montage animation. So you want to go to your main animations, and we should have an animation for our reload. So we have this reload fixed. I'm going to right click that animation and create an animation montage. So create animation montage and do a file, save all. Then for that animation montage, we can just set it in here. So we hit the drop down and select our reload fix montage, compile and save, and now we'll play that montage whenever we reload our gun. Now when it's completed playing that animation, we want to go ahead and reset our ammo or reload our ammo. So the way that we can do that is we want to set our current ammo, get that and set that on the graph and hook that up for the completed. So when this animation is finished playing, we want to set our current ammo back to our max ammo, which our max ammo size is set to 30. So we'll set our current ammo to 30 bullets out of 30 bullets. Then of course, whenever we update our current ammo text, we want to update the widget as well. So you want to get your main HUD reference and call that update ammo text event. And for the current ammo, you just want to plug in your current ammo variable as well as your max ammo variable. That way we can update the current and max ammo text on our main HUD widget. So now let's just add a comment for this. This will be our simple reload logic. And we'll just show bubble when zoomed. So let's compile and save, and let's actually go ahead and test this out. Let's go to our level and hit play. So if I fire my rifle and press R, we'll play the reload animation montage. You can see our bullets are now 30 out of 30. So I can go ahead and just dump my weapon clip till I hit 0 and press R again. And you can see that it reloaded all of our bullets, so we can again fire our weapon. So that is a very simple reload logic for our rifle weapon. So we've added our weapon. It has firing logic, reloading logic, and aiming logic. What we want to add now is a simple target that the player can practice their aim and shoot at. And this simple target will flip down whenever the player successfully hits the target. So we're going to import a custom mesh for this. So you want to head over to the project files, and in here we have a folder for meshes. And so in our main folder, we want to right click and create a new folder for meshes as well, and double click open that up. and just drag in the target.fbx, drag and drop it in there. It'll show us the FBX import options. We'll just click import all and close out of there, and it should import the target texture as well instead of the material for us. So it should automatically import that. So let's just do a file, save all, and then let's open up our target one. And in here, we're actually just going to select this material, and we're going to set this to masked. And for our mask, we're going to use the alpha channel of our texture and plug that in for the opacity mask. And that should only mask this target like so. So just save that, close out of there. And now we have our simple target mesh. So now we want to add a blueprint for this target so that when the player shoots this target, it will flip down and after a certain amount of time flip back up. So just the player will know that they hit the target. So to do that, we want to go to our main blueprints. And in our blueprints folder, we're going to right click and create a new blueprint class. And we're going to choose the class actor, the actor class. So this is a new blueprint actor. So we want to rename this to BP_target, and then let's double click and open up this blueprint. So in this blueprint, we have our viewports and we have our components. So in our components, we want to add a new static mesh component for our target mesh. So you can rename this to target mesh. And so with that target mesh selected in the details, we can set the static mesh reference. So we want to set this to our target, this target static mesh, and then we'll add that target in there like so. Then for this target, we're going to basically add some simple logic so that when the player shoots and hits this target, it will go ahead and flip down. So we want to head over to the event graph and delete all these following nodes. And basically we want to add an event for when the player shoots the target. And we're going to use damage events because in our character, we can add an event to apply damage to this actor. And in this actor, we can receive that damage. So to actually get that set up, in our target, we can right click and search for the event any damage, and that will add an event for when we receive damage. Now to apply damage, we'll actually need to go into our character. So go to your first person character, and we want to go over to our shoot logic and into our shoot function, because in here we do a line trace. If we hit something, if we hit an actor, we can apply damage to that actor. So in our case, we want to apply damage to our target, so that we can say, hey, we hit the target. So to implement that off of our hit actor, we can drag off of there and do a apply damage node, damage, apply damage. And let's plug this up for our execution. So that will be the damage actor, whatever we hit. For the base damage, we can set this to a value of say 10 damage. So 10 damage every shot. We need to plug in our damage causes. So for the damage causer, that will be ourself. So get a reference to ourself. And for the damage class, you just want to hit the drop down and select this default damage type. So now hit compile and save. So now we're applying damage to any actor that we hit. Now in the BP target, we have the event any damage to receive damage. So this will receive incoming damage. Now in our case, if this gets called at all, what we want to do is just flip this target down or rotate it down like this. That way it will show the player that they've shot the target. So in the event graph, off of this event any damage, we want to do a do once node. That way we ensure that this only gets called once before we reset it. Then we want to add a variable to keep track of whether we shot the target. So add a new variable in here and rename this to is target shot ? Compile and save. And we want to set that boolean, the is target shot, to true because now we've shot the target. Now in order to rotate our target down so that it's face down like so, we need to add a timeline to rotate the mesh. So in here, we're going to right click and add a timeline, add timeline, and we're going to rename this to fall over timeline. Then let's just double click and open up this timeline up. And in here, we can add a new track for a float track. And in this graph, we're going to right click anywhere on the graph and add a new key and select that. And we're going to set the value time to 0 and the value to 0. So it should put it all the way over here. Then right click anywhere else on the graph and add another key and select that key. And we're going to set the time to 0.3 for 0.3 seconds and the value of -90. Then click on the zoom fit horizontal, zoom fit vertical so we can see both points on our grid. Then we just want to set the length to our time, our max time, which is 0.3. Set that to 0.3 seconds. That way this timeline will only play for 0.3 seconds. So now what this should do is it should output a value that will basically set a rotation of that mesh to -90 after 0.3 seconds. So let's head over to the event graph and we'll need to plug in this to the play from start. Then for the update, we want to update the mesh rotation. So we want to get the target mesh get that on the graph and update or set the relative rotation of that mesh and update that every frame. So hook that up for the update. For the rotation, we want to right click and split the structure because we only want to rotate it on the Y axis, because in the viewport, if I select this, we only want to rotate it backwards on the Y like so. So hook up for the Y our new track, and that will set the rotation value of our target mesh. Now to reset the mesh, what we want to do is off of the finished, we want to do a branch. For our finished, we want to check and see if our target is shot. And if so, we want to reset our target is shot back to false. And then we want to do a delay because we want to wait for, say, 3 seconds before we reset our target. So to reset the target, what we can do is we can right click and add custom event and just name this to reset target, compile and save, and plug this in for our reverse from N. And we can just call that event over here reset target. So this will call that reset target over here, which will reverse this timeline from N. And when it's complete, it will call this false. So for the false, we just want to plug this into this reset. So let's double click and add some reroute nodes like so. So basically how this will work is we apply any damage to it. We'll call this node once, set the target to shot. We'll call the timeline, which will rotate our target mesh down. Off of the finish, we're going to check and see if our target is shot. It should be set to true. Then we're going to set it back to false, wait for 3 seconds, then reset our target, which will play this reverse from N. So basically, it will rotate all the way back up, like so. And when it's finished rotating, this target is shot is set to false. So then we'll go back into here to reset our do once. That way the player can again apply damage and shoot the target. It will fall over, and this will just keep looping for as many times as the player wants to shoot this target. So now we can actually test this out by just dragging this blueprint target into our game. And if we hit play, I can go up to the target and shoot it, and you can see that it flips down, and after 3 seconds it'll flip back up. So I can shoot it again, I'll flip down, and then it'll flip back up like so. So just a very simple target blueprint that we can shoot, and it will flip down if we actually shoot it. After 3 seconds, it will reset itself by flipping back up. So you can add multiple targets of these into your game by just dragging it over here. You can even create a target range by rotating this 90 degrees. Maybe we can add 3 of these. And we could take a cube over here, move this over like so, scale it down, just so we make sort of this range that the player has to practice their aim. And we could delete some of these background assets in here and maybe move these further back. We can create a simple range that the player can practice their aim so they can shoot at the targets and they'll go back up after 3 seconds. So we set up our weapon aim, we set up a simple target. What we want to add next is we need to add some recoil, because what you'll notice is we can just shoot and our weapon doesn't budge. So we have pretty much pinpoint accuracy wherever we want to shoot. So we'll need to add some recoil, that way our gun and camera will move up, which will give a little bit of difficulty for the player when they shoot their weapon. So to add some simple recoil, you want to go to your first person character and go to your shoot function. And over here at the very end, after we apply damage, we're going to add some input to our camera. That way it will move our camera up and over in a random direction to add sort of a simple recoil. So you want to search for the node add controller pitch input. So this will add pitch input to our controller or to our camera. And also we want to do a add controller yaw input. So let's hook up the execution. Now for the value, we're going to do a random float within range. And for the range, we're going to set this to -0.1 for the minimum, and the maximum will be -0.4. Then for our controller yaw, we want to do another random float within range. And for this minimum value, this will be -0.2. And then the maximum will be +0.2. So compile and save. So this will move our camera up and over in a random direction every time that we fire our weapon. So now if we hit play, if I shoot, you can see that it moves our camera all the way up. And you can see that it gives us sort of this recoil, this random recoil. And I can go over to this target. If I hold down my left mouse button, it will add that sort of recoil event where it moves our camera up. So it's a very simple recoil logic that will give some sort of random recoil pattern for our weapon. So we have our basic game set up. Now let's go ahead and actually create a custom level or a custom range level that the player can play. We'll have some unique props and we'll have our targets moving back and forth. It'll just basically be an aim range that the player can practice their aim. So let's go to our main folder and right click and create a new folder and name this to maps, where you can store our maps. And let's create a new map or a new level. So under the file, we can create a new level. So create a new level. And you have a couple of different templates to choose from. I'm going to choose just the basic template and click create. Then to save this level, you want to do a file, save current level as, and you want to save this to our main maps. And in here, we can name this to our aim level, because this will just be our simple aim level. So in here, if we hit play, you have a very simple blank level that we can start building to be sort of a range for a player to practice their aim. So the first thing that we'll do is we'll actually get some assets from the marketplace. So you want to head over to the Unreal Engine marketplace, and in here we're going to search for construction. So search for construction and filter the max price by free. And we should have this construction site volume 1, which is completely free. So you can click add to project, show all projects, and search for our FPS game tutorial. Select our project and click add to project. Now we'll go ahead and download and add that to our project. And now in our folder, we should have a new folder for construction volume 1 and meshes. And we have all these meshes that we can start building our level with. So I'm going to be using these containers, these container mesh to create sort of our level. So you can drag in a couple of these and just move these around. Now for our ground mesh, what we want to do is we're going to add a simple concrete texture. So for that, we're going to get it from Quixel Bridge, which is a free library of high quality assets and materials. So to open up Quixel Bridge, you want to click on the Q plus icon. And under here, we have this section for Quixel Bridge. So click on that and that will open up Quixel Bridge. Now, if this is your first time opening this up, it might ask you to log in. Or if it doesn't ask you, you want to click on the profile icon over here and click on the sign in. It's going to ask you to sign in with account, and you want to sign in with your Epic Games account, the same account that you used to download Unreal Engine. You want to sign in with your Epic Games account because Quixel Bridge will be free for all Unreal Engine users. So as long as you sign in with your Epic Games account, it should be all free for people who use Unreal Engine. So now that you're logged in, it should be able to browse all 14,000 free assets. And in our case, you want to go to the 3D surfaces or just the surfaces. And in here, we can search for different types of materials that we want to apply to our ground. So I use concrete for my material, and I actually use this damaged concrete floor texture. So if you select material that you want, you can choose the quality. I chose a medium quality. And to download it, you just click on this download icon, and then we'll go ahead and download it. And once it has this green checkbox, once you finish downloading it, you can click on this blue plus icon to add it to your project. What that will do is it will add a new folder in your project, and it will add that material, the damaged concrete floor material, to our project, which we can then drag and drop it onto this floor to apply that texture. Now what you'll notice is the texture is actually too big, the tiling, so we'll need to scale the tiling down. So to scale the tiling down, just open up the material, and in the material we have a section for global, and we have a tiling offset. So expand the tiling offset and click on the checkbox to change the values. So to change the tiling X, we can set this to 4 and the tiling Y to 4. And that will increase the tiling. So now if we hit play, you can see the tiling is a lot smaller. And you guys can play around with the value, but basically this is the value that I set it as. And also you can play around with the color or tint. So in the material, we can change things like the albedo. So expand that, we can change things like the albedo tint. So I hit the checkbox there and I change this to a darker gray color and just hit OK. Save that. And you can see it just darkens the color of this like so. Now let's go ahead and start working on our map. So let's go ahead and block out our level. So the way that we'll arrange this is we're going to have a simple level and a simple aim range. So let's take some of these containers and duplicate it by holding Alt. And we can rotate the containers. And basically, you can just place things around however you'd like it to design your level. And I'm going to create a simple range that the player can shoot down, something like this. Let's duplicate this over like so, and duplicate it again. You can rotate it. You can turn off rotation snapping to get a smoother rotation. Move it around like that. And we can also go to our construction volume meshes and drag in other different types of meshes, like we have this fence, construction fence. So I'm going to take that and rotate that 90 degrees, and just duplicate this like so a couple of times. And let's select the fences and move this up and over. So that will just give an illusion that there's some fence right there. And then we're going to add some barriers over here. So for that, I'll actually download another mesh from Quixel Bridge. So let's go to Bridge, and in Bridge we can go to 3D Assets, and they have all sorts of different props that you can use. So I search for barrier, and you have all sorts of barriers. And in my case, I chose the concrete barrier over here. So you can download that as medium quality and add that to your project. Just drag and drop it into your level. And I'm going to rotate this and scale this up to 1.14 like so. And we're going to move this over like that and duplicate this, and we can rotate it. So just something like that. So this is our simple range. We can go ahead and drag in our targets. So we have our main blueprints target, and I'm actually going to add a little stand to the bottom of our target. So if you open up your BP target, in here we can add in a static mesh. So let's add in a static mesh component. Select that static mesh, and in the details we can assign it to a mesh. And in my case, I'm going to go and select one of the meshes, this SM construction fence support. So select that. With that selected, we can set that static mesh to that stand. So then we can take this target mesh, and let's move this up. Let us offset it up like that. I'm going to actually take this and scale this up to 1.4 by 1.4 by 1.4. And let's just move this up more. So we have our stand. We can go ahead and take this and duplicate this 3 times. So we have our 3 targets, just like so. And if we hit play, we can see what this looks like. So we have our simple targets that we can fire at. And what you may notice is the concrete barrier doesn't have any collision. So in order to fix that, you can just right click and browse to the concrete barrier and double click open this up. And we can click on this collision button and add a simplified collision, the add 26 DOP simplified collision. And that will add a simple collision mesh to this barrier. So just save that. And now if we hit play, we cannot walk through the barrier. Okay. So let's continue setting up our level here. You can just drag in props, different props that you'd like, and duplicate some of the containers, rotate them, and position them however you'd like. And for the second range over here, we're going to take these and duplicate these by just holding Alt and dragging. And for the second range over here, we're going to take these and duplicate these by just holding Alt and dragging. And what we'll actually do is delete these, and we're going to add a track on which these can move back and forth. So we're going to add a movement so that these will move back from left to right. And so to add a little track, we're going to drag in this little construction fence support, and we'll scale this up. So I'll scale this up to 1.4 all the way around and rotate this about 180 degrees like so, and move this up. So it's just the bottom of that part showing, and then we'll just scale this up like this. So we're going to position this somewhere in the middle and something like that. And this will be basically the track on which this target will move back and forth on. So let's take that track and let's move this back here. Let's duplicate it 3 times. And then let's take this one and move this over here, and then move this one in the center. So these will all 3 rotate back and forth, and we'll need to add the logic for that. So in order to animate these to move them back and forth, we're going to add a level sequence. So if you never messed around with sequences before, you can animate objects, move objects in the level using the sequencer. This is also how people create things like cutscenes or even movies inside of Unreal Engine. But in our case, we're just going to use it to animate these targets moving back and forth. So to create a new sequence, you want to click on the sequence button icon and add a new level sequence. It's going to ask us where we want to save the sequence, so we want to go to our main folder. Let's right click, create a new folder, and name this to sequences. Double click, open that up, and just rename this to our level sequence. And what it will do is it'll open up the sequencer tab down here, which is a timeline, and we can close our content browser. So with the sequencer tab open, we can select our target, BP target for it and drag and drop it onto the graph. And that will allow us to animate and keyframe the position of this target. So in our case, we added our target blueprint. We want to click on this plus icon and add a track for our transform. And if you expand the transform, we can just adjust the location. So we want to click on this key icon, and that will add a keyframe for the current location. Then we can change our timeline to about 45 seconds and move this all the way over here. So now that it's moved at this location, we can add another keyframe for the location. And now what you can see is when I scrub this on the timeline, we're moving between these 2 points. So now we just need to go and put this at 9 seconds and put the location all the way back to its original location. So we can just copy this location and paste it. And now you can see that we've created this simple move back and forth animation. Now to stop the timeline at here, we can take this and drag it at 90. And what that should do is it should loop back and forth like so. Now we just need to animate all these other targets to move. So let's take target 5 and drag and drop it on the graph. Let's go ahead and add a new track for the transform for that one. Expand that. Let's move our timeline back to 0. Add a key for the location. Move it to 45. Let's take that target 5 and move it all the way down here and add a keyframe for the location. And then let's copy the original location and paste it down here at 90. So now we should have them both animated. Then for the last one, all we have to do is select that one, drag it onto our sequence. Again, add a new track for the transform. Expand that, add a keyframe for our location at 0, put it to 45. And actually, we're going to do this to 22 because this needs to move at this location. So add a keyframe for that location. And then we want to go all the way up to about 68. And we're going to add a keyframe all the way over here for our location. So it basically starts there, goes all the way back and over, and then copy the end location and paste it at 90. So basically it should start here, go all the way back over, and then stop in the center. So those are our animations for all 3 targets. Now to play this sequence, when we play the game, we want to first select our level sequence over here in the outliner. With that selected, we want to set this from loop. We want to set that to loop indefinitely. So that will infinitely loop. And then to play this, when we start the game, we want to click on this auto play to true. So let's go ahead and close out of the sequencer and let's go ahead and hit play. And if we go over here, we should see this automatically play our sequence and it's infinitely playing it, looping it over and over. So now I can shoot at the targets, and what you'll notice is they can flip down, they'll flip back up after 3 seconds. So we created a very simple range that will rotate and move these targets around. We have our movement targets and then we have our stationary targets over here. So now we can continue designing our level and adding more different props into our level to make it look nice. So next up, let's actually fix the lighting in our level. It's a bit washed up, as you can see, and we can just simply add a post-process volume to control the auto exposure, the lighting. So let's go to the cube plus icon and search for a post-processing volume. Drag that in here, and in the details with the post-process volume selected, we can search for infinite extent, unbound. And if we click that true, that will mean that it will apply this post-process effect to the entire level. And then we want to search for exposure because we want to set a min and max value of 1 to 1. So 1 for our min, 1 for our max. And then we'll go ahead and control the exposure. So now you can see that we're controlling the lighting in our scene. And you can play around with the value, but this is what I found works best. So now let's go ahead and keep decorating our map. And I'm going to fast forward through this part so you guys can just follow along or drag in random props and decorate the level to your liking. Another thing you can add is you can go to Quixel Bridge, and in here there are all sorts of decals that you can add. So if you head over to the decals, there are things like graffiti. Another thing you can add is you can go to Quixel Bridge, and in here there are all sorts of decals that you can add. So if you head over to the decals, there are things like graffiti, mud, leaves, all sorts of stuff you can add into your map. So I like to add these different graffiti effects. So once you add them, you can just drag the material in like so, the graffiti material, and rotate it 90 degrees. And you can just scale it down and put it anywhere on the map. Now you'll notice the normal map doesn't match up the normal of the container. So you can just go into the material itself, go to the normal intensity and set this down to 0. So again, I'm just going to add more different types of graffiti. Another thing you can do to break up the map is you want to go and open up the container and find the materials. Another thing you can do to break up the map is you want to go and open up the container and find the materials. And we actually want to duplicate these materials. So let's create a new folder and do container materials. And just copy these materials into here because we can actually go ahead and open these up and mess around with the albedo tint to give this a different tint color. So if we wanted the containers to look blue, we could set the container color to blue like so. I set both of these albedo tints to the same color. And then if we just drag in the albedo, we'll go ahead and set those tints. So we can just apply this to random containers. That way we can give it sort of different variations. And again, let's right click and duplicate these again. Open both of these up and change the albedo tint. Head over to the Unreal Engine Marketplace. Okay, so once you've gone ahead and broke up the colors, we want to add a couple of background meshes. So we can head over to the Unreal Engine Marketplace and search for factory. And you want to filter by free. And I'm going to use this factory environment collection, which is free on the Unreal Engine Marketplace. And if you go to this picture right here, basically you can see all of the background meshes that we can use. Things like industrial buildings, pipes, big containers. Now, if you download this, note that this is over 10 gigs in size. So if you want to download this, it's over 10 gigabytes. I already have this downloaded on my hard drive because it's a very good project for free assets. So here's the factory environment. We want to go to our levels in here, open up the overview level. This will show us all the assets. But basically in this level, there's a bunch of props that we can use to decorate our game. And just to grab a few, I'm going to go into the back over here and start selecting random props. So just shift select any of these props and you can grab things like these towers, these parts right over here. Just shift select anything that you want to bring with you. And basically, once you have all of the stuff that you want to bring with you, you can just right click and browse to asset, and that will select all of the assets that you selected in the viewport. And with all of those selected, you just right click and you want to do asset actions and migrate. So we can migrate it into our project. So it'll show all the stuff selected. We can click OK. And it's going to ask us where we want to migrate it to. So you want to go to wherever you have your Unreal Engine projects installed. Usually this will be in the documents under the Unreal projects. Or if you have it on a different hard drive location, you want to navigate to it. Once you're inside of your FPS game tutorial folder, you want to go to the content and just leave it into the content right here. Then click select folder and it will go ahead and migrate all those assets. So we can close out of there, and now in our FPS game tutorial, let's go to our content meshes. Should have a folder for meshes, and in that folder we now have all those meshes that we migrated. So now let's go ahead and decorate our level using these meshes, and again I'll just fast forward through this part. Okay, so now we have some simple background meshes in our game. So you can see we have various different background props and everything looks pretty good. Okay, so now we have some simple background meshes in our game. So you can see we have various different background props and everything looks pretty good from afar. So you can see all the stuff in the background and it's not too distracting. Now the last thing that we'll need to add in our game is a little bit of camera shake for our camera. That way when we're walking through the level, we have sort of this realistic head bob. So to add some camera shake, let's go to our main folder, blueprints, right click, create a new folder for our camera shake, because we'll need to create some camera shake assets. So in our camera shake folder, let's right click, create a new blueprint class of the type all classes. So hit the drop down for all classes and search for camera shake. And we should have this legacy camera shake. So select that and click select. And you want to name this to our idle camera shake and duplicate this and create our sprint camera shake, and then duplicate this again, and this will be our walk camera shake. So we have our idle, walk, and run camera shake. So let's open up our idle, and in our idle camera shake, we want to go to the class defaults over here in the details and change our oscillation duration to 0.25, and for our rotation and location, we want to expand the pitch, and we want to set the amplitude to 0.5 and the frequency to 5.0. Then for the yaw,
expand that. I want to set that to 0.4 for the amplitude, and for the frequency, that'll be 3.0. Then the roll, we want to expand that and set this to 0.2 for the amplitude and 1 for the frequency. And then scroll all the way down and click on single instance, that little checkbox. And let's compile and save that and close out of there. And let's open up the sprint camera shake. So in here, we want to set the oscillation duration, this top value, to 0.25. Then the amplitude will be 0.8 for our pitch and 18 for our frequency. Then for our yaw, we'll set this to 0.6 and 9 for our frequency. Then for our roll, we'll set this to 0.4 and 7 for the frequency. And then lastly, scroll to the very bottom and hit the checkbox for single instance. So compile and save that. And then lastly, open up your walk, camera, shake. All of these values are just values that you can play around with. But these control the pitch and yaw, basically how far up or how far down or to the left our camera should move based on if we're walking, we're sprinting, or running. So in the walk, camera, shake, set the oscillation duration to 0.15. Then for the pitch, we can set this to 0.1 and 2 for the frequency. For the yaw, we'll set this to 0.2 and 3 for frequency, and for the roll, we'll set this to 0.2 and 2 for the frequency. Hit the single instance at the very bottom and compile and save. So now to implement these camera shakes, we'll need to go to our character blueprint. So let's go to our blueprints, open up our first person character, and let's head over to the event graph. And down here, right below our simple reload logic, we're going to add a event tick. So we can do this every single frame. And the logic that we want to do is we want to right click and get our velocity, get the character's velocity, and do a vector length. Get the vector length of our character and check and see if it's greater than 0, and do a and boolean. And also check and see if our character can jump. So do that, and off of there do a branch, and we'll hook this up for event tick. So if that is true, then we also want to do another check, so do another branch. And the condition we want to check and see is if our vector length is less than 400, and plug that in for the condition. If so, we're going to play our walk, camera, shake. If false, we're going to play our sprint, camera, shake. So to play our walk, camera, shake, we want to do a get player controller. First, get our player controller reference, and then call the client start camera shake. So hook this up for the true. For this shake, this will be our walk, camera, shake. And I set this to scale to 0.001, just so it doesn't play as intense. And then I copy and paste this. For the false, this will be our sprint, camera, shake. And I set this scale back to 1. And then lastly, let's copy and paste this and hook it up for this false down here, because this will be our idle, camera, shake. And also we want to hook up the controller reference like so, and I set the scale to 0.1. So we have our idle, walk, and run, camera, shake. That will update on our event tick. Let's add a comment. This will be our camera, shake. And we'll show bubble when zoomed. So we'll compile and save. Let's play test this out. You can see that we have a simple walking camera shake. We have an idle, very subtle. You can see it play very subtly. And if I run, this is our run camera shake. And we might increase the idle. So if I go back to my idle, I'm going to set the scale back to 1 and see what this looks like. So yeah, this is our idle animation. And if I sprint, that's our sprint. And this is our walk. So a very simple camera shake to our game, which will add a little bit more of a realistic effect when we're moving, strafing, or if we're just in the idle mode. Now the last thing we may want to do is add controller input support so that we can play this on any sort of device that supports a controller, or if we want to just use the controller for whatever reason. So the way that we can add controller input support is, first of all, you want to get yourself a controller to test this out with. You don't necessarily need one, but it's just useful to have one handy. I'm going to be using the Xbox controller. So all you have to do is hook up the Xbox controller to your PC, either Bluetooth or via a USB wire. Once you hook it up to your project, Unreal Engine will notice that you have an input device connected. And now we need to go ahead and add inputs for our various different actions. So you want to go to your input folder, actions. You see we have things like sprint, shoot, reload, move, jump, aim. So you want to go to your input and open up the input mapping context. And in here we need to map our gamepad controls. What you'll notice is we already have the basic input maps for our jump, move, look, the basic inputs that come
in the first person template, but we need to add controller inputs for our sprint, aim, shoot, and reload. So to add new inputs for these, under our sprint, we'll add a new binding to the action mapping. And for our sprint, what we can do is add a left thumbstick button. So I believe this left thumbstick button is when you press down the left thumbstick. And I think that's usually what you use for sprint. If you hold down the thumbstick, it will make you sprint. For aim, we'll also add a new mapping. And for this one, this will be our left trigger, gamepad left trigger. You can add your own custom mappings. I'm not really familiar with the common controls for console for things like Call of Duty game, but the left trigger can do our aim. For our shoot, that will be obviously the right trigger. So we can do right trigger, gamepad right trigger. And for our reload, we could do the Y button or the gamepad face up. So search for gamepad face top, button top, which is the Y on a Xbox controller. So now we have our basic inputs. We have our gamepad left thumbstick. That's actually look. Sprint is gamepad left thumbstick button. Our aim is the left trigger. Our shoot is the right trigger. And our reload is the face button top. So with our controller plugged in, let's hit play. And I can look around, scope in using the left trigger. Right trigger is fire. And if I hold down the left thumbstick, that will be our sprint. The A button is to jump. The Y button is to reload. And I believe that's all that we need to set up for our controller input. So that is all for this game. If you want to learn how to actually package the game and send this game to your friends or play it on a different PC or device, all you have to do is go to your edit, project settings, and head over to the maps and modes because we need to set the default map. So under the default maps, this is the default editor startup map. So you can change this to your aim level if you want that to open automatically as the default map. As for our game default map, you want to set this to our aim level. If you have something like a main menu, you can open that up as the default map. But in our case, we only created an aim level, so we'll set that as the default map to load. And then with that set, we can go to our platforms, head over to Windows, and we want to click on the package project. Now, assuming you don't get a message asking to download the Windows SDK, if this pops open, you can go to your desktop, create a new folder, and rename this to your FPS game. Double click, open that up, and select the folder, and it will say packaging project for Windows. So just click on the show output log and dock this in layout. And this will just go ahead and package our game. And usually either you might get an error or warning, which will prevent you from packaging. If not, then it will say that the packaging has been successful. If you do get an error, it'll be marked in red. And if for whatever reason you do get an error, you just copy that message and paste it into Google. And 9 times out of 10, there's going to be someone answering or explaining what the error message is. And you'll just walk through it and basically fix the issue, and you'll be able to package your game. Now, if you're doing this for the first time, it might take quite a bit. So depending on your PC specs, it might take anywhere from 10 to 30 minutes to an hour. So this is just a good time to take a break and come back later when your project is finished packaging. So now we're back, and as you can see, when it's successful, you should see this build successful. So you should see build successful down here. Again, if you get any errors, you just want to copy them and type it into Google and look through the Unreal Engine forums or wherever people have reported those bugs or there's error messages, and just go through it and solve it, fix it, come back and repackage your game. So now I have a new folder on my desktop called FPS game, which if I double click and open up has a folder for Windows, and it has the FPS game tutorial.exe or our package game application. So if we double click and open this up, it will run our game, and we'll click allow access. And we have our simple game, our FPS game, in here that we can play. We can shoot at the targets. And also one thing that we might want to fix is our weapon shadow. We might want to hide that. But as you can see, this is our package game that we worked on. It's as an actual exe file. There's no way to escape, so you can either Alt F4. But to fix the weapon shadow, you can go into your content, main, blueprints, open up your first person character, and select the weapon skeletal mesh, and search in the details for shadow, and uncheck dynamic shadow. So uncheck that, and that will go ahead and fix the issue with seeing the shadow on the gun. Now, if you wanted to see that in the package build, you need to go ahead and whenever you make any changes to your game, you'll need to repackage the project and select the folder and click select folder. If you do it on the same exact folder, it will actually take less time than if you're packaging to a brand new folder with nothing in it. Okay, so if you just repackage to the same exact folder that you packaged before, it will just override the current package game that you have and only make changes to the following files that you changed. So as you can see, it only took about 18 seconds for our build to be successful. Now that is it for this video. In this first-person shooter game course, we covered how to create our own custom character. We showed how to import custom animations, set up our blend space and animation blueprint. We attached a weapon to our character and gave the character the ability to aim that weapon. We added things like sprint and sprint animations. We added a simple firing line trace logic. Along with that, we implemented things like bullet hole decals and hit particle effects, and we used that to create a simple blueprint target that the player can shoot and hit to practice their aim. We also learned the basics of user interface and created this dynamic crosshair with ammo widgets on our screen. And we finally created a aim range map using free assets from the Unreal Engine Marketplace and Quixel Bridge and packaged that game so we can play it on our desktop. If you guys enjoyed this full tutorial, make sure that you leave a like on this video and subscribe for more courses just like this. I will be uploading more future tutorials just like this one, so you guys do not want to miss out on any future uploads. Also, if you want more Unreal Engine 5 content, make sure you check out my other courses on my website, smartpoly.teachable.com. And yeah, that's pretty much it for this video. So I hope you guys enjoyed it, and I'll see you guys in the next one.